Simplifying algebraic fractions. The difference of two squares, if I expand the brackets, I get these terms, and the AB and the minus AB cancel. So I have two perfectly squared terms with a minus, with a difference in between, hence the difference of two squares. To factorize the x squared minus 64, I need two fully squared terms. The 64 is not a square term at the moment, so we can rewrite that as 8 squared. And now I have two fully squared terms, because what we're looking for is something in this form. Something in brackets squared minus something else in brackets squared. So I have that now. I've got x in the first one and 8 in the other one. And then we can write this as this, but the signs are always the opposites. So what you see in the first bracket goes here, what you see in the second bracket goes here, but the signs are opposites. So to factorize this expression, I need something in here squared minus something else squared. So that's going to be a 3x. This will be 4y squared, like this. And you can test this if you like. That square goes on the 3 and the x, so you've got 3 squared x squared, 9x squared. And that square goes on the 4 and the y squared, so 4 squared, 16. Y squared squared is y to the power of 4. And then we factorize. So the 3x and the 4y squared are used to make up the terms here, but the signs here have to be opposites. Example 1. To simplify, we can recognize the x squared minus 1 as the difference of two squares, because we've got x squared minus 1 squared. So factorized using the difference of two squares, and then the x plus 1 here and here cancel because we're multiplying. Fully simplified. Example 2, we're dividing by a fraction, so instead we multiply by the reciprocal of this fraction, so we need to flip this over. This is the difference of two squares. Again, we're multiplying, so an x plus 2 can cancel with an x plus 2 here, something from the numerator with something from the denominator. I can do the same with the x plus 4s here, and then x minus 4 over 3 is the fully simplified answer, or we can write it as 1/3 into x minus 4. In this example, we're going to use this in example 3. I'm going to rewrite this like this. So I need a minus 3 plus x, the opposite signs here. And then if I change the order around inside the bracket for something more convenient, I get this. So these are all equal. And you can think of this as a minus 1 on the outside, so minus 1 times minus 3 plus 3. The minus 1 times the x will give you the minus x. So example 3, to simplify, there's an x in both of these terms, we should factorize, and the same thing is true in the denominator, there's an x in both terms. Now we can cancel the x's out. When we cancel them out, we actually get a 1 for each of these, and the ones don't need to be written there, so we get this. And the numerator I can rewrite by starting with the minus, and then if I start with the x term first, it's like minus 1 times x to give minus x, and I need a minus 3 here. Minus 1 here times minus 3 gives us plus 3, so these are the same. But we can see that we can now cancel these, leaving us with minus 1. And remember, you still get a minus 1. You don't cancel these completely out and then get nothing. It's a bit like this. Let's say if you had x squared over x squared. Yes, you could just cancel them out and that should give you 1. It doesn't give you nothing, it gives you 1. It's like doing this if I divide the numerator with x squared and I also divide the denominator with x squared. And x squared divided by x squared is 1, and the same thing's true here in the denominator, which gives you 1. It doesn't give you 0. In this example, we're going to use the calculator to quickly factorize. So from the many options, it's A, polynomials, degree 2, and the coefficients are 8, 20, minus 48. And remember, what we're doing here is pretending that this is not an expression but an equation that's equal to 0. So we're looking for roots. First root, second root. So if we write those down and then make factors out of them, now these don't multiply to give us the original expression, and we can test this quickly. The x times the 2x gives 2x squared, not 8x squared. So we need to multiply by 4 out here. We need to check this multiplier each time we use this method. And just to test to make sure this is correct, 4 times minus 3 minus 12 times 4 minus 48. We can check the first term and the last one, but not this one that easily. So check the first one, check the last one to work out the multiplier here. Now if we want, we can take the 4 and multiply it into this bracket, like this, leave the first one alone. Or we can multiply the 4 into the first bracket and leave the second one alone, like this. Now when adding fractions, you've probably come across this method where you multiply the denominators together and then you cross multiply like this. And you get something like this. That's a good method, but there's a more convenient method when dealing with algebraic fractions. So starting with the same fractions, if I multiply the first fraction with 4 over 4, and the value of this 4 over 4 is 1, so I'm not changing the 1/3 because I'm multiplying it with 1, and then I multiply the second fraction with 3 over 3, and I end up with the same common denominator, 12 and 12 when you multiply these. And then simplifying, same answer as before. Example 5, we have different denominators, so to add the fractions we need the same common denominator. Now to get the same denominators, if I multiply this fraction, looking at the 3 there, if I multiply by 3 over 3 and I multiply this fraction with 2 over 2, the denominator here becomes 6x, and the same here, 6x. So we end up with the same common denominator. So we get this, simplify, simplify. The alternative longer method, where you multiply the denominators and then cross multiply, would be like this. And you can see we've already gone up to an x squared term. We didn't have any x squared terms on this side. And then factorize, cancel out x from the top and the bottom, and same answer as before. In this example, once again we have the difference of two squares, and then we can see that the denominators both have an x plus 1, but there's an x minus 1 missing on this side. So I need to multiply this fraction with x minus 1 over x minus 1. And the value of that fraction that you multiply by must be equal to 1. And if the numerator and denominator are the same, when you divide them, you get 1. So we haven't changed anything. So multiplying out here, so you've got 3x minus 3 here. We have the same common denominator. Simplifying again, or we can continue to factorize like this, just taking a minus out. That minus can be put in front like this, and once we've put it in front of the fraction, you don't really need the brackets here anymore. For practice, have a go at these questions from exercise 1b and 1c.